Greetings to Dr. Amrala, our professor, and also to the viewers. Today we'd like to present to all of you the mini project for EEE3103 on calculator. And my name is Jacinta Joseph, and my matrix number is 188408.
My name is Shazwani Afza binti Muhammad Fauzi, and my matrix number is 190447.
My name is Kanimi Subramaniam. My matrix number is 188562.
My name is Lamay Tong, and my matrix number is 188066.
Hello everyone, so I'm going to introduce you the mini project of our group. So a calculator is a device that performs arithmetic operations on numbers. A simple calculator can handle the operations of addition, subtraction, multiplication, and division. But more sophisticated calculator can handle a more complex operations such as logarithms, roots, exponential functions, and trigonometric functions. So, portable battery-powered calculators are popular with engineers and engineering students. This device allows students to solve complicated problems quickly and in an efficient manner. Calculator also reduces the problem to simpler tasks and allows the students to spend their time more about understanding the problems instead of solving the problems. So that is the introduction for our mini project.
Mini project, we have to achieve three objectives. First, to design a basic calculator program written in C language. Second, to design a calculator which is able to perform simple and basic arithmetic operations using suitable simulation software. Third, to interface keypad and LCD displays with PIC16F877 microcontroller. I'd like to talk about the schematic diagram which is drawn in frontiers. As you can see, the schematic diagram is filled out with different type of components, namely PIC16F877 microcontroller, 4x4 keypad, 16x2 LCD display, capacitor, and crystal oscillators. Top of all, I'd like to talk about the PIC16F877 microcontroller. It features all the components which modern microcontroller normally have. Due to its low price, wide range of application, high quality, and easy availability, is an ideal solution in application. As you can see in the schematic diagram, there are 8 pins connected to the keypad, 4 pins to LCD display, and 2 pins to the capacitor and the oscillator. Next, I would like to talk about 4x4 keypad. It's made up of 4 columns and 4 rows and consists of basic arithmetic operation and numbers from 0 to 9 written in each key. As you can see, there are 8 pins and connected to the PIC microcontroller. It is used to obtain the input from the user and transfer the data to the microcontroller in order to perform basic calculations. Besides, we also use 16x2 LCD display. It can display 16 characters to lines. The component code of the LCD display we use is LM016L. As I mentioned just now, there are 4 pins which are connected to the microcontroller to obtain the input from the user and display the result of calculation. The LCD display has 2 registers, namely the command register which store the command instruction given, and the data register which store the data displayed on the LCD. Lastly, 2 30 picofarad capacitor are used to store charge, and 1 crystal oscillator is used for frequency stability. The oscillator is set to 20 MHz in
logic simulation. So MPLAB is used to do the C coding and also to transfer the file into X file. So here is the simulation of Proteus. So we can see that the PIC already been connected into the components. So what we do is we take MPLAB coding, which is in X file, and upload it into PIC in order to run the simulation. So now we will run the simulation. So as you can see, the simulation will run, but the LCD will be blank first. So the user have to key in the input. So after the user key in the input, the output will be shown in the LCD. So we just did the addition. Now we will do the subtraction. So the next one we will do the division. And lastly we do the multiplication. So as you can see just now, the user used the on and C button to clear the LCD.
Hi everyone, have you ever wondered how a calculator functions? Is it magic that when you input a number into it, it's able to calculate, it's able to perform and execute an operation when it doesn't even have a mind of its own? Well, you might think so, but let's snap back to reality. The thing that enables it to actually function is all about coding. And now I would like to give a brief explanation on the coding that we use in our calculator. I'll start off with this. H includes.h is actually a preprocessor for the calculator. And moving on to void, main void, it's actually the thing that main function that actually helps in the program execution. And here main void means it does not return any value. The function does not return any value. Going on to char. Char here is not char kway teow. I know people are hungry, but it's not char kway teow. It's actually character. And I move on to the statement that we used in this calculator. While. While is actually a loop statement that we use when the action has to be performed repeatedly, but only will be able to perform it when the condition is true and terminates it when it's false. Moving on to if-else statement. If you look closely at here, this is not a common if-else statement. It's actually a nested if-else statement where we have an if-else statement in an if-else statement. I hope you get what I mean. So if-else statement actually means that even if the condition is true or false, it has a specific action that it will be outputted. Unlike the while statement, which will only be able to execute it if the condition is true and terminates when it's false. Alright, now moving on to the switch case. Right, in this switch case, every value is known as a case actually. And there will be a flow on the case statements unless if there is a break, then only the case will be terminated. If not, there will be a continuous flow in the case. At the end, as we can see, there's a default here. A default statement is actually an optional statement written at the end of the switch case. The function of a default is to actually allow the actions to be performed even when none of the case is true. Thank you.
Alright, so the objectives of this mini project has been presented in the beginning of the video. So now I would like to conclude the project. The first three is about the electrical components that is used in this project. So the first one is keypad that allow the user input of numerous and operators. The second one is programmable IC PIC16F887 that is used to carry out pre-programmed basic arithmetic operations. The second one is LCD display LM016L, which is used to to display output of numerous and operators while showing the results. Next slide, okay. So in this project, our group, have learned to use MPLAB compiler to create programs that can be compiled into .hex file and transferred into programmable IC. Okay, so the last one, we have learned to use Proteus ISIS8 professional software for the simulation of the microcontroller, keypad, LCD display and other electrical components that is used throughout this project.